Well, we've gotten to the point now where it would actually be fun to create a track list and look at results for this analysis. So we'll get to the consensus sequence and some of the other sections a little bit, but first let's look at creating some easy to examine results to see how this sequencing has performed. So to do this, what we're going to need to do is use the create track list function. So here we're going to go add element and say create track. There we go, create track list. Okay, let's bring this, let's bring this over here, and we're going to feed several things into the create track list. We'll still hold on to this variant table, and let's get rid of this variant track for right now, and we'll feed the variant track into the track list. We also have a track for the realignments that we want to feed into this track list. And the alignments will be most useful if we look at them in the context of both our primers, put that into the track list, and our workflow input, which is the genomic sequence. So let's take that, put that into the track list. The other thing we'll do, we didn't do this last time, just wanted to correct this input because we're going to have some other tables coming up later. So we'll say tables / input and variant table. Yeah, just a little house cleaning from last time. Move this over here. So what we're going to do is we're going to run this analysis. We're going to have the alignment track, we're going to have the variant track, we're going to have the genome and the primers. And let's see how this works. Let's use as workflow output. And we're going to put this, let's call this input. And let's put it in a folder called track lists. Or just tracks. No, track list. Okay. Finish there, and then what are the parameters here? There's no configuration there. And hold on one second. Oh, I see the problem here, why this is still red. So if you have this configured incorrectly, it's going to light up red. And what it says here is create track list. All tracks must also be workflow outputs. That means I made the mistake of deleting that there. And it looks like I must also use that as a workflow output too, the reads track. Okay, so let's, in order to neaten this up, we can say tracks input. Which one was this? Variants. Just save this. Finish and do the same thing over here. We have to output that into our tracks. We'll call this reads. And then also for my OCD, we'll go back here and capitalize this. Track list. Oops. Finish. Okay, now let's save this. Save as. We don't want to save it there. We want to save it in workflows. We're going to do step 9. Call this step 9 create track list. Okay, validated, saved. Let's run this and see what we get. So let's go run button. Once again, I want to select our reads. And everything else should be filled in by default because it's configured on the workflow inputs. We're going to save, create a new folder, Step 9, create track list. Okay. I'm going to pause here, and when it's done, we'll take a look at it. Okay, the workflow is finished now. Let's take a look at what we created. So I'm going to go in here, and you can see the QC reports, but we've also created the tracks and track list folders, and this is what we're interested in, the track list, the combination of all the outputs that we've looked at so far. So let's open that up. Yes. Okay, so this is what's real. You know, I definitely consider myself a card-carrying cloud evangelist. Love open source software, love using cloud computing. But I'll tell you, to create these types of visualizations really takes a lot of work. So let's see what we've created here. Okay, we have our variant track, we have our reads track, our primer track, and our genome track here. Now these aren't optimally laid out like I like them, but we'll figure that out in a second. One of the really neat features is automatically when you open this up, instead of having to click on this to look at the table down here, it automatically opens it up. And this is one of the features I really like when I'm QCing data and trying to manually go through and look at the variants is, you know, here's all our different variants. They're all single nucleotide variants. But if we click on one of these, it zooms right into the variant on the variant track. And then it shows you, here's the genomic sequence with the reference allele, and then you could see the reads and what variants are in here. So for this reason, I really, I mean, to me, this is great because now we can go through each individual variant and manually confirm what we're seeing. So this is to me is a really strong tool. The other thing that's really nice is if we expand things out a little bit, we go back to our full view, and you see we have this problem here with coverage from our tracks. Let's see if I can select that and zoom in a bit. And I'm going to get rid of this variant table down here so we could see a little better. You could see we have this problem, and because we have the primer track also in this visualization, we can go in and see which primers they are that are causing the problem. So we see this is for the Amplicon 64. These two primers, for some reason, that isn't amplifying very well there. And so you can go in and find your problem areas as well. So this to me is a really powerful tool. It's great when you're looking at one sample, but it's also it's even more powerful when you're looking at a number of samples together. But before we get to the large number of samples together, there's still a few more things that we want to iron out, which includes a simpler version of this. You don't always need the read mapping here. Sometimes all you really want is the coverage graph up top. So I'm going to show you how to create that coverage graph first, and that can make your visualizations a lot simpler because, when you rescale this and you have a lot of data, sometimes it'll sit there and you can see it churning through when you're trying to create this visualization. It's nice to have a faster view of that. And then we still have the consensus sequence and some additional QC functions. So we will move on to the mapping graph next.